So thank you for the opportunity to speak with you tonight. I really do appreciate it. It is an area that, you know, I have a passion about, global warming and what you can do about it. I also work with other businesses on what they can do to, they're not solving global warming, but they're certainly adapting. So my name is Jeff Noel. I am from the Weather Company. I have a colleague, Matthew, who you can see on the lower corner of the screen. He'll do the second half of the presentation. I want to, actually the audio, oh, there we go. I'm going to start with just a very quick video, because I think it lays the foundation for what we're doing at the Weather Company and how it works, you know, how powerful it is from a big data point of view. I just got to find my cursor again. Sorry about this, guys. Yeah. Now I got to shut the rest. Let's get rid of that. Sorry about that. I thought, you know, of course it's like a commercial, I admit, you know, but it does give you a sense of what we've done with weather, and I'll talk further about it, but it can be applied to it can be applied to you know, greater good, so to speak. So now let me just get my cursor back here. Sorry, because it's going. I have to go across screens. There we go. Let me just get going. Does that work? Great. Okay, so I'll try to quickly move through here. As I mentioned, I do work with businesses on how to adapt to rapidly, not so much the climate change, but I think one of the interesting things, and of course you in Europe have been a little more progressive about the fact that the weather is changing, there is climate change. There have been some deniers, shall I call them, in the United States. But I think we've reached a point where businesses are really paying attention. And that means that people are really listening and believing. So I hope finally we'll see some real progress towards avoiding, you know, catastrophes due to climate change. This is just something earlier I saw today from Twitter. I mean, we all know this. 2015 was a pretty warm year, so it was the warmest in the last 135 years, I guess. El Nino, we've been hearing about this. I did some work with South America. They were very concerned about impact on agriculture. And these, I just have some video images from some of the work that I've used with clients. This is actually, you can't really read them all, but they're just images from newspapers. The upper right was just from the most recent holiday period, the floods in Ireland. We also had similar floods in the Mississippi. So things are happening. Drastic things are happening. And companies are paying attention to the fact that these things are impacting companies. Governments, cities, are paying a lot more attention. So right now, as a meteorologist, it's a pretty fun time to, you get some respect, shall I say, even though everyone jokes about the weatherman. But it is kind of interesting that people now are understanding they got to really adapt to the weather. They can't let it just happen to them. This is just a few numbers. In the United States, $1 billion in claims were paid to by insurance companies for for hail damage to cars in 1 year. What does a change in temperature do to electric and energy consumption, high or low, how that really makes a huge impact. And of course, not much to do with climate change, but the reality is that weather impacts the retail buying habits of each of us today. Oops, this looks like it chopped off. As a matter of fact, maybe we'll just fly through that. Okay, I'm just going to skip these. They look like they're not rendering well. Okay. In the US, we've seen a massive increase in property losses from weather events. Certainly in Europe, you've seen that as well. I mean, reiterated, almost every client I go to here in Europe, they're concerned from an insurance company about hail and windstorms. It comes up very frequently. So as the video showed, we have a tremendous amount of weather data. And I'm going to share some information with you rather quickly, talk about some impacts, some ways other people are making better decisions, and then Matthew, my colleague back in Wisconsin, he'll take the stage and share a little deeper insight into how we did it and what type of data did we have that was used. So each one of us, weather is a daily habit. We pay attention to it. We make decisions about what we're going to do on any given day based on what the weather conditions are. I mentioned the huge impact on business. And whether this is kind of not so much climate change, but it really does depend on where you are, what a certain type of weather means to you. So it's within the context of what you're doing. And this is particularly important in retail, the impacts that it might have. So you hear the complaint that in the past that, hey, everyone's complaining about the weather, but there's really nothing you can do. Well, I'm going to argue, and then Matthew can even share in some additional information, that actually you can make far better decisions using the amount of data that's available to really make a difference, make better decisions. So why do I say that? I mean, you're all pretty technically savvy, so you know how fast things have been changing in the computer world. It's not only the ability to process the data, it's the ability to get the data. And I'll talk to you a little more about that. But just in the last 5 years, we went from updating the forecasts every 6 hours to now every 15 minutes. So much finer granularity about what's going to happen in the near future. Our company, the weather company, provides weather forecasts on a 500-meter grid around the world, over oceans, over mountains, over land. We project a forecast of what the weather is going to be each hour for 15 days out for a 500-meter grid, which equals 2.2 billion points around the world, we can be very specific about what we think the forecast is going to be. Most of you are very familiar, actually, with what we provide if you've got a smartphone. And the standard app that comes for the weather that actually uses my company's weather forecasts. And that's how we have a tremendous number of forecasts that we get. So as we mentioned in the video, we really map the atmosphere. So we're going around understanding what's going on currently and using that data to make better information available so people can make decisions. I know I'm talking a little bit about climate change, but it's more the dramatic events that are occurring because of climate change. I'm not able to forecast where, what it's going to be like in 40 years. There's a lot of different scientists that are modeling that. But I'm talking about that things are changing, things are impacting us, and we can really use the technology available to make better decisions. Matthew will go into a little bit more of this, but think of 4 different major types of data that we collect. Historical, which is very important to data scientists. This is where you can do your analytics and see how frequently things are occurring, how they're occurring more dramatically, and what the impacts are by merging that data with other data. I work a lot with insurance companies, and they're all about underwriting, coming up with the right price for that policy based on what's happening, and weather is a big impact in insurance. Then we have the current idea. We project on those same 2.2 billion points around the world of what it is doing at every given moment. Again, from your iPhone, you'll see where you are, geolocated, what the temperature likely is, and what the weather pattern is, or the weather that's occurring there is likely. And then the immediate future. This is really critical. The immediate future is a time when governments can say, hey, something dramatic is happening in a very short period of time, take action. Whether it's flooding, winds, a heat wave develops more quick, over a longer period of time than 2 hours. But even heat waves a couple of days out, it's very important to let the public know. They can make better decisions to protect themselves from things that can harm them. We have a lot of data that we get. And this gets a little more interesting, and Matthew will show you some more about this. But we have weather stations that are spread around the world that, in addition to and this is like a community effort. These are people, I have one, and probably some of you do as well, a weather station in your backyard that's feeding information out to, in this case, Wonderground. That's our weather network. And we use that data to improve our forecasts, as well as provide better information to people about what's currently happening in each of the individual places around the world. We use algorithms that we've developed, that have been developed in the science community and adopted to our purposes. We use radar algorithms. You can read around the whole arc there, that we do a lot of different things to get the data and process the data. We're not shy to adopt we have been very successful in ingesting as much data as we possibly can, as well as using other people's models that are publicly available. We have some proprietary that we use, but we're willing to take what everyone has and try to merge it and try to come up with a good view of what's likely to happen in the weather. So we do this with current. I touched on this a minute ago. We take data from what's going on in satellites. The upper left picture is about our sensor network. We take what the satellites look like, the radar, and even some government special models on the lower right, and merge them into come up with a good view of what's currently happening on that 500-meter grid worldwide. We also, on the other side, take all the forecasts and merge them. We do a statistical type of merging of the publicly available 150 weather models. And for For given locations, we use machine learning that goes back a couple of weeks to determine which of those 150 plus models are performing well and come up with a more accurate forecast. So it's a massive amount of data crunching going on using a tremendous amount of data. And much of that data we share, with our clients if it makes sense. So we get quite a bit of demand to produce some highly accurate forecasts. I'm going to just give you one example, and then I'll start to finish up. Just in October, in southern France, there was a real sudden rainstorm that came about. And one of the insurance companies that we work with in France, after the event, said, "What could you have told us that we didn't know? What could we have done if you had given us some information?" And the next two slides, and I'm going to quickly go through it, obviously there was a lot of damage. Over 20 people were killed. It was expected that it was going to rain heavily, but not this heavily. So what we went back and looked is essentially, on the right-hand side of the screen is what we saw from our weather sensor network, how rapidly it was raining. And it was pretty impressive, the amount of rainfall that was falling in a small period. We didn't forecast that there was going to be life-threatening floods. But we knew it was going on at such every 5 minutes due to our sensor network that we really went back to this insurer and said, you really could have made some better decisions if you had used some of this data. Lots of words. I was going to get rid of a bunch for tonight, but essentially, the insurance company received a lot of complaints from the public of why weren't you there for me when I needed help? Everyone was caught flat-footed. It was a weekend, so that was part of the problem, but the issue was how can, could that insurer, and it could be an example with the government, it could be an example anywhere. If you know what's happening and being able to make better decisions and not being caught in dangerous, life-threatening situations, it really would have produced a better outcome. A similar situation happened in the Caribbean just this fall as well. There were computer models talking about where a hurricane was going to go. The bottom line is someone made a bad decision, not looking carefully at the weather models and how they were being, what was really happening, and a container ship sailed right into a hurricane. It wasn't a crazily massive hurricane, but 20 and 30-foot waves essentially sunk the ship and 30 people were lost. So, we went back and looked at what did we know, and this is a lot of pretty pictures, but we do what's called probabilistic forecasting, and we look at what is the likelihood of certain scenarios playing out. And the National Weather Service in the US was claiming that, hey, it can only happen it wasn't claiming, there's always a chance of something else happening, but the public was not, and the people looking at these charts were not reading them to the sense that really there was a scenario, and that's what this other one here on the left is showing, that there really were multiple possibilities to happen, not the only one that the public service was pointing out. And the fact is, another thing did happen, and the ship sailed right into the bad storm. So the data exists. It's available. You can definitely make better decisions if you're aware of, with this additional weather data. So I'm going to turn it over to my colleague Matthew in a moment and have him talk through, give you some more details about actually going in and using the data. I wanted to share with you that it really does make a difference what we know, what you can do as a data scientist on helping people to make better decisions in a time when weather conditions are changing rapidly and unpredictably. And as data scientists, weather, and I didn't really emphasize this too much, but IBM decided to purchase the weather company. They purchased the weather company for a few reasons. First of all, we do have some pretty darn good weather information that impacts a lot of the businesses that IBM works with. But really, there was another part. And the part was we had some technology that was able, the weather company was, to ingest a tremendous amount of data and push out a tremendous amount of data. We knew how to handle a lot of the data. It's really what IBM's talking about with their Internet of Things capabilities. And that is actually, again, speaking to data scientists, you'll appreciate it. You know, you have a lot of data, you need to manage it and be able to use it. And that was one of the important factors why we were purchased by IBM. So any questions before I hand this over to my colleague? And if you don't have questions, I'm definitely going to stick around afterwards. So hopefully we can chat, you know, after the sessions are over today.
Yeah, and can everyone see me right now? Yeah. Okay. Excellent. So I'll stop picking my nose. That's a bad thing. Okay, I can see everyone else as well. Thank you. I just wanted to throw up a quick little zinger here because Jeff was talking about, you know, the importance of climate change. One thing that doesn't help in North America is, and let me share my screen here. One thing that doesn't help in North America is people tend to be fairly short-sighted. So 2014. North America was pretty much the only place in the world that had cooler than average temperatures. So we felt a little bit conceited. So it does help from a public point of view that now that warming has actually propagated into the US, it certainly makes a difference, raises awareness, and the Weather Channel is really pushing their initiatives with climate change and trying to educate the public as well. So I really appreciate the initiatives that you guys are putting together here to raise awareness. So let me switch over here to my deck. So as far as weather is concerned, I am an extreme weather geek, weather weenie, weather enthusiast. There's a whole bunch of slang terms for who we are, but it basically means we dream weather, we breathe weather, we live weather every day of our lives. It's a part of who we are, it's in our DNA. And one thing that makes weather really exciting as far as the technology is weather is on the cusp of all of these maturing technologies and is going to be one of those fields that marries all of these major data sets together. So as you heard Jeff talking about, you know, we have the Internet of Things. There is so much data out there. And in fact, supercomputers used to be, their sole purpose was running weather models. And even the first ENIAC weather model that came out, this is pretty sad, but it took 24 hours to create a 24-hour forecast. So really not much use. Since then, even just 20 years ago, a 2-day forecast 20 years ago is as accurate as a 5-day forecast is today. So the massive strides we've really been making in the meteorology field are very impressive from a technology standpoint. On the other end of the spectrum, we also have weather being ingrained in people's lifestyles. It affects their everyday life. So it's a perfect example to use crowdsourcing, which is becoming really big. You know, you guys doing hackathons. Kaggle is a data scientist. I'm sure many of you are aware of Kaggle. A lot of large corporations, as well as governments, are using it to do analytics competitions for notoriety or for a cash reward. And because of all these data sets, we need a database or a place to store all this data so we can do the analytics, and that's where the cloud comes in. And in the meteorology world, a cloud is a real cloud. It's a cumulus cloud. So that's my interpretation of that. So digging in just a little bit into how weather really affects affects all three of those fronts. You know, weather is actionable, it's relatable. So even with weather enthusiasts, such as myself, these are people going out there looking to really morally assist the field, trying to improve the technology and improve the science based on what little they can do. And you can see, just as a quick example here, you know, we're part of the Weather Channel. Our views jumped by 800% during a hurricane, Hurricane Sandy, which many of you may be aware of on the East Coast. So it's just incredible to see how many people really jump in and get interested in the weather when it's really critical for them. In addition, from the IoT story, everyone has their smartphone. Weather is the #1 reason why people check their smartphone throughout the week. It's usually the first thing they check in the morning, and people tend to check weather more than once per day. So it's just incredible how we have something that combines a real drive to understand the weather as well as the IoT associated with it. And because of that, other companies other than ourselves have also tried to cash in on this similar mentality. So a few just off the top of my head that have been raising eyebrows. Link NYC is a company that's actually going in and replacing phone booths in metropolitan areas and installing things like air quality sensors, weather sensors, road temperature sensors, to really build the amount of data that a city can work with for future planning and understanding how pollution may propagate through the city. Air Quality Egg is another one. I recommend, you know, these aren't associated with us. This is just my weather geekiness coming out. But you can buy these things for $100, really small, set them up in your house, and now you have a real-time view of air quality and can share it on the website. And then there's other companies trying to use pressure data off of phones, which we'll go to here in a second. The one downside, though, of all these companies, it takes a lot of investment to build branding and a lot of investment to become bigger than your domain, whether it's the US, whether it's Belgium, whether it's Germany. So we decided to take a different approach. Because we already have a platform that can handle an extreme amount of traffic, I mean, we're talking about billions of hits a day, we actually built a really sturdy infrastructure with APIs, so you can get weather data through points, you can get polygonal data, you can get tile-based data, to really feed any sort of platforms or any use cases that you guys would deem appropriate. And obviously, I would strongly implore all of you to head out and ask for access to our data when you guys have your hackathon towards the latter part of this year. We certainly love helping out with those endeavors. And then on top of that, I'll do some shameless plugging here. We have a couple different applications. The Wonder Station app, which is for the iPad. As well as you can go to your browser for Weather Underground. But these are ways we build visualization platforms to really showcase your data and share them with friends and family in a way that's really appealing. So we took that approach of, I'm using the Field of Dreams quote here, but if you build it, they will come. And sure enough, once we built our platform, we ended up having several sensor companies come out of the woodwork and say, hey, you know, we want to be a part of your infrastructure, of your family, so that we can get notoriety, people will buy our sensors, and we will have a really healthy partnership with one another. So because of that, and in particular, Meetup, which I believe is based out of Paris, France, we partnered with them and surged 174 countries around the world and had many thousands of additional sensors added to our network. And now our numbers are just surging. So it's just really interesting looking at an IoT story and saying, you know, it's not worth me carrying the rock up to the top of the mountain. There are many people that have already done this already and are looking for opportunities to propagate their networks, and they're looking to work with other companies to showcase them. So because of this, here's the results. I mean, today, this is just in the Flanders region of Belgium. We have 1,800 weather stations there today compared to the number of airport stations. If we're looking at Milan, Italy, and you can see the red sensors on the left, we had incredible density in downtown cities, in urban areas, residential areas, and Europe is really one of our most successful stories today. But that propagates all across the globe. You know, even developing countries, if you're talking Brazil, Argentina, South Africa, we really have sensors in place reporting back every 5 minutes, and we're storing that data away so that we can run analytics on it in the future. And that number is absolutely surging. You know, you consider only a little over a year ago, we were at less than 5 times smaller with our network, and now we're going to be surpassing 200,000 stations globally here, most likely before the end of this month. So I would implore all of you, if you want to go out and buy a weather station, you know, we're not going to stop you. That would be kind of nice. So then there's, you know, building on top of technology too, and I really wish you could see my camera because I use my hands a lot, but you're seeing a blank screen. We're also building into different forms of data that are available out there today. From a telematics standpoint, cars are able to report if their windshield wipers are running, are their headlights on. Those all have direct correlations back to what type of weather you are experiencing. Smartphones have pressure sensors in them, and if you guys have the Weather Channel app on your phone, we very well could be collecting your pressure data off of that phone that is helping build our network. From a phone perspective, and I'll get a little bit geeky here, pressure isn't the best because you could be higher up in a building or you could be in a car that has a higher pressure. But something like pressure change is something much more universal. And through the sheer number of phones out there, it actually has some incredibly valuable data. You would know when a cold front is moving through, where it has impacted a certain part of the city. You'll know where winds are hitting a city from a thunderstorm. Really incredible the type of data that you can pull out of these sensors that are just sitting in your pocket. In addition, our business connections are also giving us additional data that other companies don't have access to. You know, we're currently collecting weather data from planes. We have 85% of the US market right now and about 20% of global market in aviation. And these planes all have sensors that are reporting the temperature, reporting the wind speed, reporting the turbulence every 20 minutes as they fly through the air. So another really incredible data set that we are building all into our infrastructure. And this makes a big difference. I heard Jeff talking earlier in his presentation that you know, we take a statistical approach. And because of this, we can actually use the ground network that we have to prove which models are performing the best from one area to the next. And this directly relates to areas that have really complicated coastlines or complicated terrain. You know, coastlines, mountains, our models drastically improve in areas that have really interesting geographies. So we consider this an incredibly valuable data set, and it's only growing for how accurate we are at forecasting. Even from a distance standpoint, that green line represents the average distance of a sensor in an area like Europe and the US. Blue is more global, but you can see how much that line, as you go to the left dragging down, how much improvement you get in the forecast by being within within about 8 miles and even 2 miles of a sensor makes a huge difference in accuracy in the forecast. And then talking about, Jeff was talking about the France scenario. Airport sensors tend to report once every hour, so you really only get a fairly fragmented snapshot of what's going on the ground, whereas our sensors can update every 5 minutes, and sometimes every second you can be getting this live information. So you know exactly when the winds hit a certain location or exactly when the rain starts falling. You can track that across an urban environment. Really exciting to see the implications of that, especially in things like emergency management, where often they're waiting for the next hourly OB or the next 6-hour model run to make their decisions. So I took the liberty of checking out station counts in the Yorkshire and Lancashire areas of northern UK. Back in December, area was absolutely inundated with about 7 days worth of flooding. Really horrifying situation up there. And using our personal weather station network, we can really get a very high resolution look at where did that heavy rain fall? Where did that rain fall? Which rivers are actually going to be the ones targeted the most from these heavy rains moving from upstream? So similar to the France example too, getting that data every 5 minutes, what's the rain intensity? You're getting this on a granularity that allows emergency management to make better decisions. I also, this is something I implore for everyone in the room, there's also some really interesting derivative data sets that you can start deriving once you have a network of this intensity and this resolution around the world. And one thing that popped to mind for me, you're getting this information, I can look at the historical every 5 minutes. I can look exactly when this sensor went offline and what the weather conditions were at the time that that sensor went down. And sure enough, and I'll show you actually a tornado case as well here in a second. But these are sensors that basically went offline in Vancouver, British Columbia from a major windstorm where half the customers actually lost power. And you can see as we march through the times, you can actually see which areas are most strongly affected by those, by the winds, which areas are actually getting knocked out with power. And even our utility companies, I'm not entirely sure how extremely advanced the utilities are in Belgium, but even this type of data is extremely valuable to a utility company. They just don't have the infrastructure in place to know just lost these 20 homes off the grid, we just lost these 20 homes off the grid. So it gives you a really hyper-resolution look at the situation on the ground that can be used for things like emergency management or outage prediction. So, and I know Jeff probably went through this slide as well, but wrapping everything together, this analogy has fallen on deaf ears a couple times, but I'm going to try it again anyway. We've been storing this data for years. We have about 10 to 15 years worth of personal weather stations. And we have our own QC algorithms in order to improve the data. But there's only so much value with the technology we have today that we can actually pull out of that data. Hence one of the reasons why we partnered with IBM. And I look at this like nuclear energy or nuclear fuel rods. The technology today, we can use up maybe about 80% of those fuel rods, and then we store them away in a bunker to hide them away from radiation. But what we're finding is, as the technology gets better and the analytics gets better, there's actually more data and more value to be refined out of that data set. So just like fuel rods, now we're kind of pulling them out of the bunker and reusing them to get another 15% of value. I look to you guys, data scientists of the world, to really take the data that we have and find the additional value, find those new ways to dig into the data sets to make differences in all different business lines, whether, as Jeff said, in retail, emergency management, we have disasters occurring, so the more we can help with planning, with emergency management, the more we can save lives. And even trying to understand how air quality plays a role in health over time. These are all big questions that we're going to have to figure out as we look at the changing world under climate change and the more frequent natural disasters that we're going to be subjected to. So I really appreciate it. I'll open it up here to questions. I know we're closing right about to break at this point.
Okay, are there any questions you would like to ask? Yeah, yours. If I'll repeat the question, so if you say it loud enough, I'll repeat the question.
So the last thing he mentioned is that he's looking for complementary solutions, like is there already search or research of air quality and healthcare? Do they already collect the data of air quality and that they correlate it with healthcare?
So did you hear the question?
Yes, yes. So air quality already, air quality has a direct effect to health, and there are correlations, even finding things as close to if you live within 1 or 2 miles of an interstate or a major throughway, you actually will experience more frequent asthma effects by living in those areas. So there's not only a very micro-scale environment, but you also look at countries like China, where the amount of pollution they're pumping out, the amount of smog, and I think even in the UK, they just trashed their, I believe it was their carbon monoxide numbers for the year in the first 7 days of this year. So it's a very real problem, and understanding how pollution behaves based on weather is a really important topic that needs further study.
Next question, please.
What proportion of your data is publicly available, is open source data? And if there are open data, how can we access it?
Sure. So, and I heard that one as well. Thank you. Let me jump up here to, so one area that you guys can go to today, we've already been working with the IBM Wolfmix platform. And this is really a programmer's portal, really easy way to connect modules together with different data sets. So if you're looking to build some really fun applications using forecast data, this is all our data sources, our forecasts that you can get through the IBM Bluemix platform. And this is free to start tinkering around with.
Another question, please. Yeah.
I think in the beginning you mentioned something about retail and the effect of weather on retailing. Can you elaborate a little bit on that? On what level of granularity was that, and on what scale did you look at that?
Well, there's been a lot of different reports. Even the Royal Meteorological Organization put out a paper about the impact of weather on retail. And it's actually a really cool big data problem, because some of the things that the buying patterns that we have as consumers are not so obvious, actually. And so a lot of data mining has gone into what, and usually commercial efforts. Companies say, why are we selling more of this and not that? And that has been very interesting, just all sorts of gems come out of that. I'm not sure if we have any, specific correlations. I will.
So I got a couple So there's some correlations that really just make sense. For example, if it's warmer, people tend to buy more ice cream. But some data sets that people don't expect is once the temperature gets above 25 degrees C, sales of ice cream actually go down because people think it's going to melt before they can get home. Another one that really doesn't make much sense, but Scotland, and even further north, they buy 3 times more barbecued goods when it's 20 degrees C versus the rest of the UK where it has to be 24 degrees C. So you see these really microcosm, micro-ecosystems that really affect heat.
And one other place, if you're interested, there's I guess it's a web page, but Forecast Factor is very focused on retail. It happens to be from our company, but all sorts of gems are put out there about what has been discovered about data in retail. If you're curious of following it, and actually some of the stuff, like Matthew has pointed out, is rather surprising, but it makes sense when you dig underneath it. But that can be entertaining to follow.
If you're in the US and there's a hurricane, you're 7 times more likely to buy strawberry Pop-Tarts. It's just how it goes.
Okay, we have time for one more question. Yes.
So what's the most interesting application that you have with a utility?
You got that on application for utilities?
So one platform we're actually working on with IBM today is called OPRO, and it stands for Outage Prediction and Resource Optimization. And what they're actually doing is they are trying to predict based on the models, and it includes everything from weather to how much leaf coverage is on the trees to how much the wind speed's going to be, to determine what is the likelihood of seeing a certain level of power outages. And that way, the utility can position crews in the right locations. So that would be part A. Part B, which is also somewhat an emergency management tool, but you can consider any sort of resource optimization would use something similar to emergency management, where you're positioning resources to take care of problems. We are also working with the IOC, which is called Intelligent Operations Center for Emergency Management Platform within IBM. And that's a product that they sell directly to large governments, and they also sell to people like utilities to see if there is, I'll use, because it's close to me, New York City, when Hurricane Sandy moved through, you could use that platform to determine if this substation goes down, then all of these assets will also be impacted. And that's another really important aspect that plays a role in utilities.
Well, thank you very much, Matthew, for this very interesting presentation. For your information, your presentation will be captured and put on our YouTube channel, so you can you'll be able to listen to yourself and see how well you've done the presentation. Jeff's presentation will also be there, so you can see Jeff's presentation as well. Now, as you know, we will be at the Hadoop Summit in San Jose, end of March, or maybe if you are there or somebody from the weather companies over there, we could.
No. I'll make sure it's me. We want to get out of Wisconsin for winter. Okay.
Well, we'll be looking forward to meeting you there, and we'll probably bring some Belgian beer for you, so that you know what we've been tasting, or we'll be tasting about 1.5 hours from now. Thank you very much, Matthew, for being here and sharing all this knowledge with us. Thank you, Jeff, Noel, for being here, and let's move on to the next. Thank you.
Hey, I hope you liked this presentation. This presentation was held in the Brussels Data Science Community Meetup. If you want to know more of when these meetups are taking place, just check the link below. Bye-bye.